Bonjour mon ami and welcome to today's little installment of my little channel. Yes, I'm so glad to see you here. And what are we dealing with? Well, we are dealing with rotation. Yes, rotation, and it's a continuing of a little bit of series I've been doing on transformation. So if you haven't watched the other videos, please go and do. Now, one last request from me. Have you subscribed to my YouTube channel? Now, don't worry about it. I've got all of about 8 people watching. I'd like to make it to 10 before the end of the weekend. Can you help? Well, if you can, there is a little doohickey over there, a red arrow, that'll say something along the lines of show some support. And if you can click that, that would be greatly appreciated. And also, tell your friends. You have friends? I mean, you're very lucky. I don't have any. But if you can tell your friends to click on that and subscribe and watch the videos, I'd be deeply grateful. Now, rotation. What are we going to do this lesson? Well, I suppose the key thing is to know what it means to be a rotation, to know 3 things that define a rotation. I'm going to jump ahead, but direction, angle, and center of origin. To be able to draw an object with a rotation that's defined, to be able to find the rotation, and to be able to understand what is meant by a rotational symmetry. All very exciting. And later on, at the very end, we're going to do something on GeoGebra. Now, if you've never met GeoGebra, it is freaking awesome. It's a great piece of software that does all this exciting stuff for you. So, as I said at the start, what do we deal? We've already done a video on reflecting shapes. We've already done a video on translating. And if you remember, reflections can happen by looking and flipping things in the x-axis and the y-axis and all sorts of stuff like that. What is the translation is to move. And if you haven't seen that video, I spoke really bad French. I thought it was quite good French, but apparently my friends in the United Kingdom said it was fairly shonky. So anyway, but once we've done these 3 things, we're going to move on to a video called congruence. And congruence is fabulous, or congruence, as someone said. It's congruence. Moving on. So, what is a rotation? What can you see behind me? And no, you can't go, you spin me right round, baby, right round. Yeah, I know. Weird, huh? All right, what about a little bit of Kylie Minogue? Yes, I'm spinning around. Don't know the words. Yes, I think she's got it. Yeah, I'm not really sure. Have you ever wondered what they do at concerts? They go, oh. And actually, if we go back to you spin me right round, baby, right round. What was that music video all about? Look, it's random. You know, what are they wearing? So a rotation is basically one turn. Yes, so what are things that rotate? Your bicycle tires, car tires, the washing machine, I don't know. My random sense of humour seems to go in rotations. But the point of it is, when something turns through 360 degrees, it's called a rotation, or randomly over here in Australia, a revolution. So we're looking at things that go around in circles. And I've sort of said here, let's name 3 things that define a rotation. If I told you now to turn 90 degrees, have you done it? Because that would be weird. But if you've turned 90 degrees, awesome, but did I tell you which way to turn? Because when I did this recently with my class, I asked them to rotate 90 degrees and they turned completely different directions. Most random thing I've ever seen in my life. And so telling someone to turn 90 degrees is awesome, but let's now say, I need you to turn 90 degrees clockwise. So we define 2 things as clockwise and anti-clockwise. Now there is no way on this camera I'm going to get this right, but clockwise as I'm looking at it, is that way around. It is the angle or the hands of the clock. So I'm assuming for you guys it would be this way around. And anti-clockwise for you guys would be clockwise for me. All right, so if you don't know, look at a clock, which is a bit tragic really, because how many of us actually have real clocks anymore? We're all digital. We've all got Apple Watches and Samsung Gear S3s. Samsung Gear S3, good watch. Anyway, so we've got their direction clockwise and anti-clockwise, or if you're in America, maybe counterclockwise. We've got an angle. Now I've said 90 degrees, but generally speaking, we can turn any number of degrees between 0 and 360. But the most common ones we use are 90, 180, 270, and I suppose 360 degrees. But if you turn 360 degrees, you're going to end up way back where you started from. So we've said there are 2 ways of turning, clockwise and anti-clockwise or counterclockwise. Now as I draw it, there we go, that way is clockwise, and if I was to turn the other way, that would be anti-clockwise or counterclockwise. So it's important. And a little bit later on, I show you an example where I use 2 pieces of paper to do this. And so it becomes a lot more obvious there. The angle we are turning. Now I've spoken a little bit about that just then. Generally speaking, At your level, we will deal with 90 degrees, 180 degrees, 270 degrees, and probably, possibly 360 degrees. But just remember, 360 degrees is a full turn, so it's a bit pointless because you're going to end up exactly where you started. Now, what about 180 degrees? Well, do we need to know the direction we're turning if we turn 180 degrees? And if you don't think you do, stand up, turn 180 degrees clockwise. Now, go back to your start position, turn 180 degrees counterclockwise. What do you notice? You're exactly the same point. So when we have 180 degrees, there is an argument amongst maths teachers, and wow, we get vicious. There are handbags flashing around everywhere. But the point of it is, it's like, do we put the clockwise? Do we put the counterclockwise? Do we miss it off? My advice to you is always put 180 degrees and a direction. It's better to get it right by writing too much than getting it wrong by not writing enough. There are other ways of talking about angles, and one of the best ones I think is compass points. Never eat soggy Weet-Bix. Just the idea now of eating soggy Weet-Bix makes me just a little bit nauseous. But the whole point of it is north, east, south, and west. I could say to you, okay, everyone, face north. Again, where is north? Very confused. But we could define where north is. So imagining I'm looking at the camera now and saying turn north. I could now say to you turn and face east. Now, we can turn 90 degrees, or we can turn 270 degrees. Now that direction becomes important, because 90 degrees will have me facing east that way, and 270 degrees that way would have me facing east as well. So that's why direction is really important. I'm sure there are other ways we can talk about angles, but they are the two most common. Now, this center of rotation is also really, really important. When you turn, generally speaking, I'm assuming you're going to turn as if we've nailed your feet to the ground. Now, obviously, I don't want to do that. That sounds incredibly painful and quite sort of ridiculous. So we would imagine that our feet are stuck in place and we would just spin around that one point. But what if actually I said to you the center of rotation was in the center of the room you're in at the moment, or the center of a field outside? Well, that would change things quite significantly. So here is a triangle. If I mark X as my center of rotation, then when I rotate that, let's say 180 degrees clockwise, then what's going to happen is I'm going to end up with my shape looking like this, because that corner is pinned. That's where I'm pivoting it around. So that corner will stay static. But if I was to have this shape here, but now my center was there, we would need to take account of that distance around. Now, I urge you, grab a bit of paper, have a go at doing this, and I'll show you again how to do this in literally 30 seconds. But now, if I was going to rotate this, I would end up with my shape looking like that. No longer is it pivoted around this corner because we've got this center there. So those three pieces of information make rotations really, really exciting by changing them up. But for every single rotation you have, you must have all those three dictated. All right, how to easily draw a rotation. Now, as it turns out, I've recorded a video for this, so I'm just gonna sit back and kick off my shoes, have a cup of tea. Actually, this is real tea, and it's good. Mind you, it's 30 degrees here in Australia at the moment. I think it was 34 earlier, and I'm drinking a hot cup of tea in the studio with lights. What am I thinking? Okay, over to you, Darren. Go. Actually, doing a rotation is bizarrely rather easy. Why? Well, because all I need is, yes, a piece of paper. And you're going to say, what do you mean you need a piece of paper? Well, actually, it just fascinates me how simple this is. So imagine I now have this shape here, a triangle with vertices A, B, and C that I want to rotate, I don't know, let's write 90 degrees, and I want to go clockwise. And I'm going to have the origin as my center of rotation. So I've got my three important points. So the first thing I'm going to do is actually put a piece of paper on top, and you're going to go, but hold on a moment, you've actually hidden it. And I'm going to say, yes, while you won't be able to see it, as I look through this, I can trace where my axes are. So what I'm going to do is I'm actually going to do a reference point. Now that cross there actually lands over my cross here. So when I put that on, it gives me a reference point where I'm going to rotate it around. And what I'm going to do is I'm going to trace my actual triangle. So there is my triangle drawn really badly. So there is my triangle. I don't need to color it in, I just thought I would. Can you see? Hopefully you can. Now, what I'm going to do is I'm going to take a pencil and I'm going to stab it here in that center mark. And you're going to say, why? Because what I'm now going to do, trying very hard not to have my hand, I'm going to turn this top piece 90 degrees clockwise. Now you're going to say, how do I know it's 90 degrees? And actually, this cross point here has now matched up beautifully with my axes. So I am now going to stab through 1, 2, 3 vertices. So I've used a sharp point. Now obviously most boys out there will just be like stabbing stuff going, yeah, this is funny. Please don't, that's random. I'm going to remove what is effectively my tracing paper, and I'm going to change my color, and I'm going to go 1, 2, 3. And ladies and gentlemen, using nothing more than that piece of paper, I now have B dashed, C dashed, and A dashed. And I can do that as many times as I like. If I wanted to do 180 degrees, go back to my piece of paper, put it back over as my reference point, put my point in there, and now 180 degrees. Now if I'm going to turn 180 degrees, it doesn't actually matter whether I go clockwise or anti-clockwise. I'm just going to go 1 quarter turn, 2 quarter turns. It lines up, and 1, 2, 3 points. Remove it. I've got my reference now, and I can go 1, 2, 3. And once again, I've now got C dashed. This will be B dashed, and that will be A dashed. And literally, there is nothing more to rotations than that. Oh yeah, okay, sorry. Oh, good cup of tea. Good cup of tea. So, do you see how simple that was? Just putting one piece of paper on top of another, marking out a reference point for where you're going to rotate around, but also so that you know where the 90 degrees is. It doesn't get any more complicated than that. I promise you, it's rotation is so easy. Now, obviously, having had an opportunity to draw rotations, we then need to know how to read a rotation. So this question here is taken from the Cambridge Essentials textbook series, which is what I'm using to teach for. And it is a fabulous resource. But basically, it just wants to know, can you tell me or describe the rotation of this object? So let's say this is my object, and let's say this one's my image. How have I gone from my object to my image? Well, that arrow's given me a huge hint. So the first thing is I'm moving counterclockwise, all right? So I'm moving anti-clockwise. So that's my direction. What about the angle I've turned? Well, hopefully you'll all be happy that it's 90 degrees. So that's awesome, but I also need to say where it's been rotated around. And in this situation, my center of rotation is point C. And in an exam or in a test, if you were doing that for me, I would give you all the 3 marks that you would be allocated to that question. If it's a 1 mark question, that would suck massively, because if you miss one of those pieces of information, you've lost all the marks. But I've got my direction, I've got my angle, and I've got my center of rotation. Again, it doesn't get any more complicated than that. What about finding the center of rotation? Yeah, this is going to be a great video, relatively quick. Well, here is a triangle. And let's imagine over here is my other triangle. Now, this isn't going to work beautifully because I don't have it accurately. But what I need to do is, if this is A, B, and C, so this is my object, and then we are turning this around. So this is B, C, and A, all right? And we've got to put the dashes on to show that that's my image. Then the way to do this is actually connect each of the like points together. So what I'm going to do is point C, or vertex C, I'm going to connect to vertex C. Vertex B, I'm going to connect to vertex B. And vertex A, I'm going to connect to vertex A. And it just so happens that where all those dotted lines cross, and I know there are 2 of them on top of each other, happens to be my center of rotation. Wow, what would the angle be? Hopefully you're all happy it would be 180 degrees. What would the direction be? Well, because it's 180 degrees, I can choose clockwise or anti-clockwise. It doesn't actually matter one way or the other. So finding the center of rotation, just take vertices, join them together, and where they cross is where the center is. Now, in a previous video, we dealt with lines of symmetry, which was awesome and really simple. What we said was, if we had a shape, let's call it a rectangle, for example, for ease of use. Where could we cut this, or how many times could we cut it through the middle such that it looked the same above the dotted line as below the dotted line, or whether we could fold it over and it would fit each half would fit properly on top of each other. So with a rectangle, that was nice and easy because there was one there and there was one there. So we said that had two lines of symmetry. Yes, symmetry is looking the same. So what about rotational symmetry? Well, rotate means when we turn. So I suppose putting those two words together says, when I turn this shape, how many times does it look the same? Well, theoretically speaking, I could turn this over and over and over and over again. So the question is, how many times do I turn it? And I suppose the obvious answer there is just once. So when we turn something 360 degrees, how often or how many times does it look exactly the same? Now, the good news is I've got an example here as well from Cambridge Essentials textbook, which again is a fabulous textbook. And here is a shape. And what it says is, how many times will that shape look the same if I turn it through 360 degrees? Now, the good news is the start position, which it's in at the moment, stands for one order of rotational symmetry. Listen to what I said there. One order of rotational symmetry. So we define these things in terms of orders of rotational symmetry. So every shape has one because it looks the same at the start and the finish. So now when I turn this shape around, and I can't do it visually, I wish I could, but imagine turn it around, halfway around it would look exactly the same. So it would have another order of rotational symmetry, and then spin it again and it would go back to the start. Now we've already counted the start as one. So in this situation here, we would describe that that has order 2 rotational symmetry. And in all honesty, you have to write that, order 2 rotational symmetry. That's what's going to get you the mark, particularly the order 2, because that's important. Now, actually, pretty much that's this lesson done. There is nothing more I can teach you with rotational symmetry. It's about turning, and if you remember those 3 pieces of information, we need to know the direction, we need to know the angle, and we need to know where it is rotating about, that origin, that center of rotation. I don't think there's anything else particularly complicated to do this. Now, as I promised, I'm going to hand over to myself. Now, it'll be voice only because I'm going to talk and record my screen while I use GeoGebra. But it's a fabulous piece of software, and there is a link, ladies and gentlemen, there. Now, I have to promise you that I am no genius at using this. I have literally been playing, and it is awesome. So the first thing we're going to do is we are going to do a reflection. Now, I know that's not quite the point of this video, but if you load up GeoGebra, and the link is being shown by the red arrow now, I am going to put 3 points for a triangle. Let's choose a nice easy triangle. So there's 1. Oh, look at it. It even puts the letters for you, A, B, and C. Now, what I'm going to do is I'm going to connect those together by clicking on lines. And I click and drag between the 3 points. And wow, it is so clever. It actually joined those together. Now what I'm going to do is, as I say, a reflection first. And I want to reflect in a particular line. And in this situation, I'm going to reflect in the line, the y-axis. So what I'm going to do is, again, just create a line running straight the way down. So I've got my original shape and I've got my mirror line. Now when I scroll all the way down, you'll notice there's a transform section. And one of them says, reflect object in line. So I'm going to click on that and it gives me helpful instructions. Now sadly, you can't see them because they've just gone off the bottom of the screen. But what it says is, select the objects to reflect, which I've done, and then click in the mirror line, and lo and behold, that is freaking awesome. And if I wanted to, I could draw another line, this time on the x-axis, connect it to there, and click to do my transform, select the object I want to reflect, and the line I want to reflect in, and wow, this stuff is just awesome. So scrolling out a little bit there, and moving my axes up a little bit, and let's get rid of that point G because I don't want it. All right, so that was a reflection. What about a translation? Oops. What about a translation? So what I'm going to do is I'm going to edit by selecting my shapes and delete, and then get rid of this line here and that point there. All right, so there's my original shape. What did I want to do? A translation. Well, again, I'm going to go to my transforms. And that says translate by vector. So select object to translate. There we go. And then by a vector. Okay, so now when we want to translate by a vector, this is a little bit weird. With all the questions you've done, you'll be given the vector through which to translate. And if I had the vector say 2, 3, where 2 was on the top and 3 was on the bottom, what you do in GeoGebra is you actually have to physically draw this. So here you see a line, and when I click on it, it says vector. So if I want to go 2 across and 3 up, what I do is click and go 2 across and 3 up. And I actually draw an arrow that goes 2 along and 3 up. Now, when I want to transform that, I go down to my transform. Again, click on translate by vector. Highlight my shape. Click on my vector. And lo and behold, there we have our translation. Now, it seems a bit weird, but actually, I quite like that. That's quite funky. Now, the one we were dealing with just a moment ago was, or this video was about, rotations. And so I'm fairly sure it's going to want me to rotate about a point. So there is a point that I've rotated about. Let's just move this up for a moment. And now it'll say, let's go down to our rotation tool, which happens to be this one here, transform rotate around a point. Click on it and it says select the object to rotate, then the center point, and then enter the angle. So if I now go 90, notice it's already got the degrees in for me, and it says, do I want to go anti-clockwise or clockwise? Let's go clockwise and click OK, and this stuff is awesome. Let's do a different point. Let's actually rotate it around point B. So I don't need to put a point in there. I'm going to click my shape, and then I'm going to click point B, and I'm going to say, can you rotate it 135 degrees? Oh, let's be funky. Let's do 135 degrees anti-clockwise. Wow! Again, this stuff is amazing. GeoGebra does so much. And in fact, that triangle I could have drawn as a polygon just by clicking 1, 2, and 3. And notice when I close it back up, I now have my polygon. I could have done that as well. I could have done a hexagon, all sorts of different shapes. Oh, regular polygon, I want 4. Well, that was awesome. It actually drew it all for me. Whoa! Anyway, I'm getting too excited. If you can, load up GeoGebra and have a play. It is flipping awesome, okay? But I'm pretty much now going to hand back to Darren, who is me. Yeah, enough. Wow, wasn't that interesting? I love that piece of software. It is freaking awesome. So, what I'm going to ask you to do now is do me that honor of just clicking that subscribe button if you would, if you haven't already done so. Deeply, deeply appreciative. And if you're not or you've already subscribed, then there's a video loading for you over there. As is normal, it is lovely having you. I look forward to seeing you next video. MaffsGuru, out.